Hey Scott, hey, thanks for coming to Engineering 3D. I really appreciate the time coming to Milwaukee here and visiting with the GSC team and 400 users. It's been awesome, and your keynote was just fantastic.
It's a great event.
Thank you very much. And the thing was that really interested me, your position now with Stratasys, you're the Chief Innovation Officer.
Right.
Can you talk just a little bit about that?
Sure, we're focused on bringing new things out, proving the concept, proving the feasibility, and then moving that into engineering to provide it as a product. And that's my world. That's
awesome.
Been my world, and that's still my world.
You know, one of the things that really impressed me, because my background in aviation and aerospace, I'm real interested in, I saw you showed the infinite build table, and those types of tools that you're showing with Boeing and some of the other companies out there. How long of a part can you build?
We've built parts in the 30 and 40 feet, but over time I think we'll be building practically up to 150 foot in terms of either parts or forms and tools for like carbon layup tools, and that's needed for the aerospace industry.
That's awesome. So, you know, one thing I keep thinking about, and I call it the cigar tube, but it's the fuselage. Will you guys ever build something like that, a fuselage, a plastic fuselage, or
I think
carbon?
so, yeah, especially when you get into either the carbon-filled fuselage as well as wings. I mean, we could be able to print a full unmanned drone.
Wow, we should do that. That'd be awesome. So, and the other thing that really impressed me too was the robotic arm. I mean, you know, today everyone's talking about automation and that type of thing, where you know, you're watching the arm. It's literally unlimited with motion. And so, tell me a little bit about what you're doing there.
Well, we're partnering with Siemens, which has both the controls, the NX, and we're putting the FDM head with one or two tips on it, and then doing 8-axis motion to be able to build complicated shapes that are more normal to the surface rather than just planar. And then these are going to go on to real production lines, both in aerospace, but also a lot in automotive.
Fantastic. You know, one of the things in your presentation, you guys started the company, I think it was in '89?
Yeah.
And that's the same year we started our company. So I look back at our partnership, and it's been awesome working with you guys and being a partner.
It's really been a great partnership.
And we've had a lot of fun. I can't tell you how much fun we've had at all these events and traveling around the world and that type of thing.
We've been doing the leading edge and trying to stay out of the bleeding edge.
Yeah, right? Yeah. And the thing that I always think about is the .com era and the point of time that it took to get to where we are today. It took about 20 years. And I'm looking at, you know, Stratasys and the same type of thing, you know, where it took a number of years really to evolve the product. And now the technology is so awesome that we've got out there that it seems like you guys are starting to develop more product, a lot quicker, a lot bigger, a lot of materials and those types of things. And so what's the future for Stratasys?
Yeah, it's a really good analogy, and we've lived through it. I think within 3D printing, we started out focused on just models and concept models, and I think that's evolved to the point where now you can get real precision parts for manufacturing. You can get real continuous production of parts. So through automation, you get the consistency and the reliability of part output. And now there's a whole world of metals as well.
That's great. Well, thank you, Scott.
Yeah, thank you.
Live from E3D 17, right here in Milwaukee. Thank you.
Thanks.